Good evening. Today we're going to do a video on the definite integral again with the absolute value as a piecewise function. Thought it was worthwhile to spend a little time on this again, so we'll knock it out. Alright, so here we have an integral of the absolute value of x squared minus 4 dx between minus 5 and plus 5. Okay, so first off, we're going to direct ourselves to this idea of piecewise function, because now we have to know how this is going to work out, and the way I do that is I use what is called the sign chart. Okay, and this sign chart is going to show us where on a number line this guy is positive or negative, and where he transitions from being positive or negative, and we have to treat those parts as a piecewise function. So let's take a look at what we're talking about. So what we do is we set these f of x here, this function inside, okay, which is equal to absolute value x squared minus 4. We remove the absolute values and we set f of x equal to 0. So that would be x squared minus 4. Okay, and then we solve this, and if you notice, this happens to be the difference of two squares, the difference of squares, okay, type of function. Okay, so I have here x squared minus 2 squared, and when you have that kind of function, the way you factor it is you would get x plus 2 and x minus 2. So therefore you would set x plus 2 equal to 0 and x equals minus 2. And then you would set x minus 2 equal to 0. You get x equals plus 2. Okay, so these are your two critical points, okay? There's your two critical points on a number line, and you would put them minus 2 plus 2, and that's when this guy actually equals 0. And there's your plus x, okay? So on the number line, he equals these values 0 here. So what we're after is the sign over here, and the sign over here, and the sign over here. Okay, so we could put a value in here by putting minus 3 into the function. So if you did do that, you would take this, you would put, okay, so f at x equals minus 3, and I would get a minus 3, okay, squared minus 4, and that would be 9 minus 4, which really what we're after is that it's plus. So over in here, we would get a plus value. All right, somewhere in between these, we would then probably just use 0. So we use x equals 0, and then I would get 0 squared minus, this is your function here, x squared minus 4. That's your f of x, okay? So you're putting it basically in the function, and you're finding out what would come up in this space between these two critical values, and that would be a minus 4. So I have a minus sign here. And then I would put something in here, okay, and I would say, all right, let's put positive 3 in there. So I would get a positive 3, f of x equals plus 3. I get a 3 squared minus 4 is 9 minus 4, and again I get a positive. So over here would be your positive, the function's positive. And all that makes a lot of sense, because if you plotted this guy just as f of x equals x squared minus 4, you would get something that looked like this. Okay, and it would come back up. But that's not what we have. We have f of x equals x squared minus 4 absolute value. And if you recall from doing your absolute value functions, this guy would come down here at -2 and +2, and he would come down, but then he would jump up positive again, and then he would take off back up. Okay, so this is what's going on at -2 and +2. So we're seeing we would have gotten a bunch of minus uh, area down here, and with our function, we're looking at doing uh, this. So we have to break this guy up. We're going from -5 all the way to +5. Okay, +5. So we've got some area over here, which will be plus. We have some area over here, which will be plus, and then we have to doctor this area because it would have been minus. Okay, and we can't have that because we have the absolute value. So the way we're going to fix that is with a piecewise function. And what I mean by that is between the interval of where x is, so we're looking at f of x here. Okay, we have x squared minus 4. So when we're looking at the area where uh, we are between less than 2, okay, where x is less than -2 rather, we're going to go with the standard function, x squared, okay, minus 4. And when x is greater than +2, we're going to go with x squared minus 4, okay? But the problem is when we're dealing with in between these, we have this negative value of area, which we have to negate. So we're going to negate the entire function. So we're going to put a negative x squared minus 4 for anything between these two values. So when x is what? Less than um, uh, +2 or greater than -2. And what would that become? That would become minus x squared plus 4. You see? So it's a different function. Okay, so that's going to be what we're going to integrate. This is what we're going to integrate in here. And in here, this would be -2 less than x less than +2. And then we're going to integrate this guy up here. So watch what this integral becomes. So we have here -5 to -2. We're going to integrate the regular function. X squared minus 4, okay, dx. And then we're going to go from -2, okay, to 2. We're going to do this other function, okay, which would be minus x squared plus 4, okay, dx. And then plus, we're going to go from 2 to 5 of the original function, x squared minus 4 dx, okay? So there you go. And so now I'm going to run the numbers on this and do the integration. So here I get x to the third over 3 minus 4x, okay, between -5 and -2, and then plus minus x to the third over 3 plus 4x between -2 and +2, and then plus x to the third over 3 minus 4x between 2 and 5. Okay, so, and you would get the plus c here, but as you know, with the definite integrals, the plus c is going to cancel out, so I don't have the plus c as I would when we're not dealing with definite integrals. Okay, let's put in the numbers. So I have the upper limit here. I have -2 to the third power over 3 minus 4 times -2. Okay, then I'm going to do minus here. I'm going to have -5 to the third power. Okay, uh, over 3 minus 4 minus 5. Okay, close that up. And I'm going to start with the middle now. Plus, all right, another section here, a minus 2 to the third over 3 plus 4 times 2 minus a minus negative 2 to the third over 3 plus 4 times negative 2. Okay, and then the third part here, I have 5 to the third over 3 minus 4 times 5 minus 2 to the third over 3 minus 4 times 2. Okay, close bracket. And all of this here is going to become 27 plus 32 over 3 plus 27, which if you put these together will give you 194 over 3 is 64 and 2/3. And there's your final answer. And if you notice, you're getting all positive stuff here from all three of these areas, and it makes sense that this area would be equal to this area, so the 27 is making sense, and then you have roughly another 10 in the middle here with this semicircle almost. Okay, so that's how we deal with the piecewise function definite integral of an absolute value. Tricky, but doable, and keep your eye on the function, what it looks like, and break the functions up and think about what you're being asked. Because if you just did the regular definite integral of this function without the absolute value, you would have a negative 32 over 3 added in to these two numbers, and you would end up with a different number. Okay, that concludes this video.